Hi guys, welcome back. So we're going to continue on chapter 5. We're going to move on to lesson 5.3, which is graphing radical functions. So let me present my screen and we'll get started. Okay, so for lesson 5.3, as I said, we're going to be graphing radical functions. So first, let's define what a radical function is. A function that contains a radical expression with the independent variable in the radicand. Okay, the radicand is what we call the stuff that's under the square root or cube root, fourth root, the radical sign, right? So 3x plus 6 is the radicand. Up here, just x is the radicand. So we're going to be looking for a variable under the radical. Okay, so when you see a radical and a variable under the radical, that's your hint that you're looking at a radical function. All right, so it's important to know the parent functions because when we get into the transformations, which we'll go through in just a second, the rules look very similar to when we studied the transformations of quadratic functions and polynomial functions. So we're going to be talking about translating right, left, up, down, reflecting, horizontal stretches and shrinks, vertical stretches and shrinks, and I'll review that with you guys for a second or in a second. But knowing what the parent functions look like so you have a general idea of what the graph should look like before it is transformed is a good idea. So the parent function for the square root function, which is f of x equals the square root of x, okay, this is what the function looks like. And the two key points to know would be 0, 0, 1, 1, and then the other one would be 4, 2, right? If you have an x value of 4, think about if you plug in a 4 here and you take the square root of 4, your output's going to be 2. So it would be 0, 0, 1, 1, 4, 2. The next good point that would be used for graphing purposes would be like 9, 3, because when you take the square root of 9, you get a 3. All right, so those would be the key points that I would use to graph my square root function. For your square root function, the domain, well, as you can see, I'm going to call it the starting point, right? It's at 0, 0 at the origin, and then the graph is moving, the parent function is moving up and to the right. So the smallest x value that we have is a 0. We don't have any x values over in quadrants 2 and 4, so I don't have any negative x values. I also don't have any y values down in quadrants 3 and 4. So that means my y values are going to be greater than 0 as well because there are no negative y values. Okay, the parent function for the cube root family, which is f of x equals the cube root of x, this is what the graph looks like. Okay, so excuse me, some key points, as you can see here, are 0, 0, 1, 1, negative 1, negative 1. And then if I wanted other points, I would think about numbers that I can take the cube root of easily. Maybe like 8, right? The cube root of 8 is 2. So it would be 8, 2, and then negative 8, negative 2, okay? And so on and so forth. So the domain and range for this situation is all real numbers. As you can see, your function starts at the origin. I'll say it starts at the origin. It doesn't really start there, but you have a point at the origin and it goes up and to the right forever. It's also going down and to the left forever. So I'm going to have positive x values. I'm also going to have negative x values. So the domain is all real numbers. And the range, well, I have a y value of 0. And since the graph is going to constantly move up, I'm going to have y values positive, but I also have y values that are negative since the graph is moving down and to the left. So domain and range, both of them is all real numbers. All right, so the rules, as I said, for the transformations look very similar to the rules that we've studied all along this year. Okay, so here's the notation, x minus h, and then we have f of x plus k, and then so you can look at the notation. Again, it's exactly the same notation as all the other transformations we've studied, but maybe more importantly, kind of look at the examples and see if it makes sense to you. All right, if under the radical you have an x minus 2, that's 2 units to the right. Here, if it's x plus 3, it's 3 units to the left. Now, if the value is not under the radical, if we have plus 7, we're moving 7 units up, minus 1, 1 unit down. Under the radical, the x value is changing, so it's a negative x. That's going to be a reflection in the y-axis. If the negative is out in front, it's going to be a reflection in the x-axis. Okay, if we have a value under the radical, like we do here, 3x, that's going to be a horizontal shrink by a factor of 1/3. Here I have a horizontal stretch by a factor of 2. And if the factor is out in front, all right, here I have a vertical stretch of 4 and a vertical shrink of 1/5. Again, the rules are very similar to what you guys already know. All right. So for the practice exercises, in examples 1, 2, it says graph the function, identify the domain and range of each function. Now for these, we could graph them by hand, okay? We absolutely could. We'd probably want to try to think of numbers that we could plug in for x that when we multiply with a -3 is going to give us a nice value to take the cube root of. However, I am going to just use a graphing calculator with you guys to help us graph these. So pull up your graphing calculator, and it's important that you know how to plug these into the graphing calculator, so make sure you're taking the time to do it. I'm just realizing now I probably should have zoomed in on the screen for you all to see a little more clearly. There we go. Maybe that's helpful. All right. So the first function, I'm going to go to, not graph, I'm going to go to y equals. And the first function that was given, it was a cube root. So to get cube roots, I'm going to push math and then go down to option 4. You could also go to option 5, right? If you go to option 5, that lets you put in whatever index you want. So in this case, it's a cube root of -3x, and then I'm not under the radical anymore, plus 1. All right, now we could talk about the transformation, and we'll do that in other problems in a second, but we know that this plus 1 is shifting the graph 1 unit up. We know that when there's a negative under the radical, a reflection in the x or the y axis, so you could look back at your table to see it's going to be a reflection in the y axis. That factor of 3 is going to be a horizontal shrink by a factor of 1/3, okay? So I'm going to hit graph, and there is my graph. So then I'm going to hit second table, and I'm probably just going to list some good points to help me graph, okay? Maybe some of these decimal values aren't the best, but maybe I use -9, 4, and 0, 1, and 9, -2. I mean, you can absolutely use the decimal values, but you know, they're a little more, you're just kind of approximating when you graph them, when you plot them. So, all right, so I would use -9, 4, 0, 1, and 9, 2. All right, so when I make my x and y axis, since my x-axis, I have to go out to 9, both right and left, I'm going to have to change my scale. Okay, maybe I count, let's see, 2, 4, 6, 8. Yeah, if I count by 2s, it'll work. 2, 4, 6, 8, 10. So it's -2, -4, -6, -8, -10. Now my y, I could change the scale as well, or I don't have to. It won't be drawn to scale, but that's fine. So -9, 4, 0, 1, and then 9, 2. All right, so right now, if I didn't know better, it almost looks like a straight line, but I know what the parent function of a cubic function looks like. So I know what kind of shape it needs to take, right? It's not going to be a straight line. It's going to look something like that. And if you want to use some of those decimal values to get some more points to give you a better shape graph, you can absolutely do that, okay? For the next one, using my graphing calculator again, all right, so this time it is a 2, and then in parentheses, x minus 5 to the 1/2. Oops, I should have done alpha y equals, put my fraction there, 1/2, and then -4. Okay, so one thing that we know from previous lessons that I'm going to point out before I actually go ahead and graph this, another way of writing this function, what is, or how can I rewrite 1/2, that fractional exponent, that rational exponent, how can I write that in radical form? The bottom number tells me what root, the top number tells me the exponent. So another way of writing that is 2 times the square root of x minus 5. Is that a minus 4 on the out yet? Minus 4. So now I know it's a square root, right? The parent function is square root. It shifted 5 units to the right. It shifted 4 units down, and there's a vertical stretch of 2. Okay, so I could type it in that way as well. And maybe I will just to show you. All right, so it's not letting me, let me go down. There we go. Okay, so I could also type it in as 2, and then I'm going to have my square root of x minus 5 and then minus 4. All right, I think I typed that in correctly. So let's see, let's graph it. Okay, so you saw quickly it graphed the blue and then quickly it graphed the red right over the blue. It's because they're the same function. All right, and then I'm going to go second table to find some good points. And I see all these errors, right? That's because there's a restriction on the domain. Oh, and we were supposed to talk about domain and range for the last one, which I didn't. So we'll go back and do that, but we can talk about it here first. So there's a restriction on the domain. All right, when I plug in 1 for the x, it doesn't work. 2 doesn't work. 3 doesn't work. 4 doesn't work, but 5 does work. Okay, so we'll talk about that in a second. That has to do with the domain and the range. All right, so some good points to graph would be like 5, -4, 6, -2, and then maybe 9, 0. All right, so over here. So I said 5, -4, 6, -2, and then 9, 0. Now I can start my y-axis all the way over here instead of in the middle. That way maybe I don't have to change my scale, right? If I count 1, 2, 3, 4, 5, 6, 7, 8, 9, now I don't have to change my scale. So 5, -4, 1, 2, 3, 4, 5, 1, 2, 3, 4. And then 6, -2. And then 9, 0. And we know what the parent function looks like. So there we go. Now the domain and range, which I need to go back for the other problem and talk about in a minute. The domain. Okay, this is, again, think of it kind of as your starting location. Here's my starting location, the x value there. What is it associated with? Well, what's the coordinate, right? 1, 2, 3, 4. It has an x value of 5. This has an x value of 6. This has an x value of 9. So the smallest x value is a 5, and all the x values are moving to the right. So they're all going to be greater than 5. So x has to be greater than or equal to 5. Your range, which has to do with the y values, the lowest y value is associated with this point. Okay, that has a y value of -2. This has a y value of I said the wrong thing. This has a y value of -4. This has a y value of -2. This has a y value of 0. So -4 is the smallest y value, and all the y values are going to continue to increase as we move up along our function. So y has to be greater than or equal to -4. All right, coming back over here, where my graph looks something like this, right? There were no restrictions. Your domain is all real numbers, and your range is all real numbers. Okay, positives, negatives, 0 are going to work for the x value, and you'll get those positive, negatives, and zeros as outputs for your y value. Okay. All right, it says describe the transformation of f of x equals the fourth root of 2x plus 5 represented by g of x equals -4th root of 2x minus 5. Okay, so here is my original, it's not a parent function, but here is my original graph. Here is my new. What happened? Okay, so I can see here that I had a positive, now I have a negative. So what does that do to the graph? It's a reflection over the x-axis. Reflection over x-axis. All right. Now, right now, again, think about the parent function. If you think about the parent function, this is up 5 units from the parent function, and this is down 5 units from the parent function. So from positive 5 to negative 5, how many units is that a change of? I think about the number line from positive 5 to negative 5. That's a change of 10 units. You translated down 10 units. Translate down 10 units. All right. The next one says write a rule for G if G is a horizontal shrink by a factor of 5, 6. So I'm thinking automatically horizontal. That should be inside the parentheses with the X, and it should be the reciprocal. Okay. Followed by a translation 10 units to the left of the graph. All right. So let's first take care of the horizontal shrink. So with the horizontal shrink, it's going to be the cube root of 15, and then inside the parentheses with the X, 6/5 X plus 1. All right. And then it says translates 10 units to the left. 10 units to the left means I'm going to have a plus 10 underneath the radical. Okay. So when I simplify that off, I have that g of x is equal to the cube root of 15 times 5, 6. So 5 goes into 5 once, 5 goes into 15 3 times. So it's really just 3 times 6, which is 18. X plus 1 plus 10 gives you an 11. So that would be your function. All right, let's look at the next one. Use a graphing calculator to graph 8x equals x squared plus 5. Identify the vertex and the direction of the, that the parabola opens. Okay, so in order to use our graphing calculator, if you take a quick note, notice how we have to have it in y equals form, right? Both of our, no matter what line I use, it's y equals y equals. So first step is to get it in y equals form. So I want to get y by itself. So get y alone. So if I have 8x equals y squared plus 5, I'm going to subtract the 5 from both sides to start. So I have 8x minus 5 equals y squared. Then I'm going to take the square root of both sides. Don't forget your plus minus. So y equals plus minus the square root of 8x minus 5. So when using my graphing calculator, I'm going to graph it as y equals the square root of 8x minus 5 and y equals the negative square root of 8x minus 5. Okay, so let's take a look at our graphing calculators once we plug that in. All right, so I have, let's see if I can click on it. Oh, nope. I need my square root symbol first. The square root, nope, that's not the right button. I'm trying to see what I'm doing with all the writing over top. It's kind of hard. Let's clear that. Okay, so it's the square root of 8x minus 5. And then it's the negative square root of 8x. Now, before I push graph, let's think about what we think this is going to look like. Where's my minus? Sorry, I can't talk and think at the same time. All right, so we have a square root function and another square root function. The negative out front tells me it's going to be a reflection, right? So it's going to be a reflection over the x-axis. So if I have a square root function and then another square root function reflected over, there we go, I'm going to hold my hands this way, over the x-axis, okay, think about what that's going to look like. So now if I hit graph, there we go. So here's my square root function, and here's the square root function reflected over the x-axis. Looks like a parabola, right? Looks like a sideways U. So the question then says, use a graphing calculator to graph that function. Identify the vertex and the direction the parabola opens. So we can see that the parabola opens. Oh, my pen. We could see that the parabola opens to the right. All right, now, oh, right off the screen, sorry. And now we want to know what the vertex is. All right, so let's go to the graphing calculator for a second. Okay, so to figure out the vertex, all right, what do you think we should do? Think about it for a second. Well, maybe we should write the equation for the parabola and then look at it from there. Okay, so let's think about that for a second. I'm going to erase all this. Yeah, I'll erase that for now. Let's think about this. When our parabola is open to the side, right? Whenever we had a parabola open to the side, that was when the equation was in the form x equals 1 over 4p or x equals a, depending on if it was 1 over 4p or a, and then y minus k squared plus h. You guys remember this from our unit on parabolas? All right, so I know we solved for y so that we could graph it using the graphing calculator, but now let's solve the equation for x. So I have 8x equals y squared plus 5. I'm going to divide everything by an 8. So I have x is equal to 1/8 y squared plus 5 over 8. All right, so now whether I compare it to this function or that function doesn't really make a difference. If I want to know my vertex, and your vertex is h comma k, all right, can you all see, or sorry, your vertex is it's going to be, yeah, h comma k, sorry, that was right. So your vertex is going to be 5/8 comma 0, okay, because your h value is the 5/8, and there is no k value. I could rewrite it, oh, I'm too low off the screen over there. I could rewrite it as y minus 0 squared plus 5/8 so that you could see that is a k value of 0. Okay, so there's your vertex. All right, so I'm going to sketch the parabola. You can do that on your own, but that's how you'd approach that problem there. Okay, the next one, use a graphing calculator to graph x squared equals 49 minus y squared. Identify the radius and intercepts of the circle. All right, so same thing, we want to solve for y so that we can plug this in our graphing calculator. So solve for y. So x squared equals 49 minus y squared. Solving for y, let's subtract 49 from both sides to start. So I have negative y squared equals x squared minus 49. Now I'm going to divide everything by a negative. So y squared equals negative x squared plus 49. Now I'm going to take the square root of both sides. So y equals plus minus the square root of negative x squared plus 49. Okay, so in my graphing calculator, I'm going to plug in y is equal to the square root of negative x squared plus 49. Oh, off the screen. I'm going to move that over just a little bit. Y is equal to the square root negative x squared plus 49. And I'm going to plug in y is equal to negative square root of x squared plus 49. Okay, so let me erase all this so it doesn't show up on my calculator. Grab your calculator. Oh, clear out those two. So I have square root and then negative x squared plus 49. And then I have negative square root of negative x squared plus 49. And then I'm going to graph it. So I have a circle. Okay, so what we're going to do here is identify. It says use the graphing calculator to graph, okay? And if you guys were sketching, if you were sketching this and you needed to know what coordinates to plot, I would go over to my table and look for some good coordinates like 7, 0. All right, all the rest were going to be errors up there. Oh, and then 0, 7, and 0, -7, okay? And then -7, 0. So it keeps using like -7, 0, 7, 0, and that's going to be something we talk about. So let me graph it real fast. All right, so we had -7, 0. We're a little bit off, that's okay. It's -7, 0. And then we had 0, 7. A little bit off as well. And then we had 7, 0. And then we're going to have 0, -7. All right, so looking at my circle, that is a terribly drawn circle. Right, hopefully you understand and can see that the center is the origin 0, 0, and the radius is 7 units. And how did I know that from the graph? Well, from the origin 7 units up, 7 units to the right, 7 units down, 7 units to the left, right? Those are all your radii, because the radii is equidistant from the center of the circle to each outside point of the circle, okay? We're going to learn more about the equation of the circle moving forward, but for now, this is as much as you need to know. Okay, let's keep moving along. Oh, that's it. That is it. It was a shorter lesson. All right, guys, so that is it for lesson 5.3. Let me stop presenting. So I will see you back here for the next lesson. Bye.